which operation I'm doing? We are working with OR operation, that is we are working with addition. Instead of writing 2z, I'm just going to write it only one time. So that zy plus z will be as it is, remaining value will be as it is. So as I told, if it is a normal variable, that will be 1. If it is a complemented one, that will be 0. Then we are dealing with minterm. Hello everybody, welcome back to the session 4 on chapter 2, that is Boolean Algebra. I am Rohini TS, lecturer, Department of Computer Science, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. So in our previous session, we had discussed regarding some of the laws of this Boolean algebra that I have discussed regarding commutative law, and also we had discussion regarding associative law, distributive law, along with absorption law, and I have discussed about the most important topic, that is De Morgan's theorem. So in this, we have two kinds of De Morgan's theorem, that is De Morgan's first theorem and De Morgan's second theorem. That is what I have discussed in my last session. So in our today's session, we will be discussing about how to simplify or simplification of Boolean expression, and also in that we have two kinds. One is algebraic manipulation and another one is using Karnaugh map or K-map. So in our today's session, we will be discussing about this algebraic manipulation, and also we are going to discuss regarding the minterm, maxterm, most important topic for 2 marks, and also we are going to learn with this canonical form. We'll see the first thing. So in that logic diagram. So in this slide, we are going to learn how we are supposed to write the logic diagram. So now we got to know that what do you mean by Boolean algebra, what are the laws we have to follow, everything that we got to know. So and also we got to know what you mean by product, or when it is odd, or when it is ANDed, everything we have discussed. So based on that concept, we'll write the logic diagram. So we are going to use only 3 logic operators, that includes AND, OR and NOT. So by making use of all those, we are going to write this logical diagram or logic diagram. Let me write the expression. Consider x into y dot z. So what do you mean by this? So which operations I have here? I am doing with a dot operator. That is what we are dealing with, a product, that is multiplication. If it is a multiplication, which logic operator we have to use? That is AND gate. So first let me consider this within the bracket, that is y dot z, that indicates y into z. Then which logical operator I am supposed to take? That is AND gate. Consider this y as one input and another input signal as z. So this will going to give me y dot z. But here what we have, I need to multiply that with x. So how can I do that? By adding this one. So this will going to give the resultant. This will be the resultant. So this is what x value. So y into z, that will going to give us y dot z. If I added or if I ANDed this with this x, that will going to give the resultant. Then how it will be? So x dot y into z. How can I do that then? So within the bracket what we have here, that is x, y. So x, y, I will going to AND this with z. So this will going to give the resultant. This is z value and this is the value of x dot y. This is how you are going to write the logic diagram. Let me take one more example. X bar plus y bar is equal to x dot y whole bar. So what is the first input I have here? First you have to understand which operation I am doing. We are working with OR operation, that is we are working with addition. So that x bar, so that is NOT gate. That will be my one input. This will be x, this become x bar. So next what I have here, that is y bar. Let me take one more variable, y. So if it is knotted or if it is complemented, then it will become y bar. So which operations I have in between? That is addition. So that I need to perform or I need to have a OR gate. So this will going to give us resultant. So next, what is that? X dot y whole bar. So here I am going to take x and I am going to take y. AND operation we have here, and I am going to write the and I will add not to it, then it will become NAND. So that is what? xy. Then the output will be xy. If I added not get, it will become x by whole bar. This will be the resultant. This is how we are going to write the logical diagrams. So take some more Boolean expression and write this logic diagram. We'll see the next concept, that is what? Simplification of Boolean expression. So as I told, in order to reduce the complexity, we are going to do the simplification of Boolean expression. So that simplification of Boolean expression can be done with two methods. One is algebraic manipulation and another one is Karnaugh map. In short, it will be termed as K-map. So we'll see about the 21 laws of this Boolean expression. Already I have discussed regarding all these laws. So we got to know that if I get 0 plus x, so then what will be the value? That means if I add any value with 0, I am going to get that value. That value can be either 0 or 1. So in the same way, if I multiply any number with 0, that will be 0. In the same way, we have 21 theorems or 21 laws we have in a Boolean expression. So by using that, we are going to do this algebraic manipulation. We'll see the first question. In order to solve or in order to do the simplification of Boolean algebra by making use of this theorem. So what is the first problem that I have here? X bar y bar z plus x bar y z plus x y bar. So here let me take the question first, that is this one. Next you have to check, do we have any common variables among these two? So here I have common variable called x bar and z. In these two expressions or in these two values, I have common variable called x bar z. So I will take it out, then it will become y bar and y. Then I will write the remaining value as it is, that is x dot y bar. So as per the rule, we know that y bar plus y. So if I add any number with its complement, then that will be equal to 1. So by replacing this y bar plus y, I am going to write 1 in the place of that. That means x bar z into 1 plus x y bar. So then if any values multiplied with 1, then we are going to get the same value. So that is x bar z plus xy bar. So can I get any common factors out of these two expressions? No. So this is the simplified version of this Boolean expression. We'll see the next one, xyz plus xyzw plus xz. So if you observe this one, these two values, we have some common variables, that is xyz. So I'm going to take this xyz as a common factor. Then 1 plus w will be odd value plus xz. So after that, as we all know that if I add any variable with 1, then it will be 1. So 1 plus w is equal to 1 itself. So you can see here 1 plus any variable will be going to give us 1. So in the same formula, I am adding this w with this 1 so that it will going to give me 1. So that xyz into, so bracket, that means we have a product here. So it will be into 1 plus xz will be as it is. So after that, if you consider this xyz into 1 will going to give us xyz itself. So after that I have xz. So if you consider these two expression, which is the common term in the both of the expression, that is x and z. So I will take this x and z outside. Then y will be remaining value plus xz. In the place of that, I am going to write 1. So as we know that if I add any number with 1, then it will going to give us 1. So that xz into, in the place of y plus 1, just I am going to write 1. So then if I multiply any number with 1, it will going to give the same values or a variable. So that the answer or simplified version is xz. This is how we are going to simplify the Boolean expressions by making use of these theorems. We'll see the next question, that is z of y plus z into x plus y plus z. So now I have to multiply this z with y and I have to multiply this z with z. So how can I do that? Z into y zy plus z is zz. Then the remaining values will be as it is. So after that, we know this rule, that is z into z. We are going to get z only by using which theorem? That is theorem 6. So that out of this law 6, x into x is equal to x. In the same way, z into z is equal to z. So instead of writing 2z, I am just going to write it only one time. So that zy plus z will be as it is, remaining value will be as it is. So in each line you have to check, can I apply any of the theorem to this particular Boolean expression. So if you consider this one, zy plus z, though that is somehow equal to what? This theorem 16, that is x plus xy is equal to z. That means instead of writing this zy plus z, I am going to write that only as z, because in the place of x we have z and in the place of x we have z again and y. So this will be equal to z itself. So that here we are, instead of writing this one, I am just going to write this as z. Then we have x plus y plus z, that is with a product. So that z into x plus y plus z. Now I have to multiply z with all the three variables. So that zx plus zy plus zz. Already we know about this zz. So instead of writing zz, I will just take z. So the remaining will be zx plus zy plus z. And we know that we have common factor z in all the three expressions. So I will take it out. Then it will be x plus y plus 1. So as we all know that if I add any number with 1, then we are going to get 1 itself. So that this x plus y will be considered as one term. So it will be considered as one term and I will add that with 1. So it will going to give us 1. So that z into 1, if I multiply any number with 1, then it will be that variable. So that z will be the final answer for this Boolean expression. So the final answer is z. In the same way, we are going to solve this problem also. We'll see the next topic, that is regarding minterm. So what do you mean by minterm and what do you mean by maxterm? It's very important topic for 2 marks question. So what do you mean by minterm here? Minterm is a product of all the literal with or without bar within the logic system. So minterm is a product of all the literal. That literal can be either with or without bar. So if it is with bar, then that is complemented. If it is without bar, that is a normal variable. So that you can see here, a variable may appear either in its normal form, that is x, or in its complement form, that is x bar. So here it can be x, that is a normal variable. If it is x bar, that is a complemented form. So here you have to understand one thing. If a variable value is 0, then it is a complemented value. So if I have x, then it will be equal to 1. If I have x bar, that will be equal to 0. In the minterm, which is the minimum value, that is 0. So the complemented one will going to get 0 and the normal variable will going to get the weightage of 1. That is minterm. So now we'll see how we are going to represent that minterm. So as we all know that we have two variables x and y. If it is two variables, then it will be 2 power 2. If it is 2 power 2, I can get 4 combination. 2 into 2 will be 4. I can get 4 combination for this x and y variable. So that 0 0 1 1 0 1 0 1. So what did I told? If it is minterm in the sense what? 0 will be assigned to x bar. So for normal variable, the value will be 1. So what we have here in the first row, 0 0. So that what I am supposed to write? X complement and y complement. That is what? X bar, y bar. Then 0 1, x bar, y, 1 0, x, y bar, and 1 1. So both are normal variable, so it will be x. Then how we are going to find this designation? That is what? So already we know about 4 to 1 format. So here we have only 2 variables. So if both are 0, then it will be 0. So then we have 0 1. In the place of 1 we have 1. So its designation will be 1. So 1 0. So in the place of 2 we have 1. So it will be M2. So next we have 1 1. So 2 plus 1 will be 3. So its designation will be 3. So in that way, we are going to find the designation. So we'll see the same thing for 3 variables minterm. So we have x, y, z. So if it is 2 power 3, then it will going to have total 8 combination. So 4 zeros, 4 ones, 0 0 1 1, 0 0 1 1, 0 1 0 1 0 1 0 1 and then 0 1. So here you can see the minterm for this one. So wherever we have 0, in the place of that variable, we are going to get the complemented value. So that x bar, y bar, z, then 0 0 1, x bar, y bar, z, 0 1 0, x, y, z bar, 0 1 1, x bar, y, z, and 1 0 0, x, y bar, z bar, 1 0 1, x, y bar, z, 1 1 0, then x, y, z bar, 1 1 1, so that x, y, z. And we got to know how to find the designation, that is by making use of 4 to 1. So wherever we have 0, no need to add that value, but wherever we have 1, so we have to add that place value, so that we can have M0, M1, M2, M3, M4, M5, M6 up to M7. So this is how we are going to write the minterm. So now we'll see some of the problems which is related to this minterm. So find the minterm designation for the following. So we have to find the designation. So as I told, if it is a normal variable, that will be 1. If it is a complemented one, that will be 0 when we are dealing with minterm. So if it is x bar, then what I am supposed to write, 0 or 1? So it must be 0. Then in the place of y bar, I have to write 0. In the place of z, I have to write 1. So 0, 0, 1. So if it is 0, 0, 1, if I consider 4 to 1 format, so 0, 0, 1. So if I add this, what is the value? That is 1. So its designation is 1. We'll see the next problem. A, B bar, C, D bar. So here it will be 1, it will be 0. So for C, we have 1. For D bar, it will be 0. So now I can't take 4 to 1. I have to take 8, 4 to 1 format. So 1, 0, 1, 0. So 8 plus 2 in the place of 2. That is 10. So that its designation is M10. So this is the easy way of finding the designation of given minterm. So next, what we have here, what are the fundamental products for each of the input words ABCD is equal to 00, 10. For if it is 0, what I am supposed to write? A bar, B bar, and consider this value as C and consider this value as D. So here I don't have complement, so it has to be normal variable. Then we have 0, so it must be D bar. So we are finding the product of all the variable, so that A bar, B bar, C bar, D bar into, then what is this? 110. So that A, B and C bar. It must be like this. Next, here 111, so it needs to be normal variable and 0 needs to be complemented, so that A, B, C, D bar. So we have found the products for each of the input value. We'll see the next question. What are the fundamental products for each of the input words ABCD is equal to 0010, ABCD is equal to 110, ABCD is equal to 11110. Write SOP expression, that is sum of product. So we have to perform the operation sum for the product. So let me consider. So if it is a normal variable, it will be 1. If it is a complemented one, that will be 0. So wherever we have 0, there you have to put complemented version of this variable. So it will be A bar, B bar, then C, D bar plus. So that is sum of product. Sum of product. So next what we have? 110. So that A, B and C, in the place of C, write C bar plus next 11110. So that A, B, C and for the D we have complemented. So that we found this SOP, that is sum of product. So these are all the products. So and we are performing addition, that is sum of product. This is how we are going to find the minterm values. We'll see the next one, that is related to maxterm. So maxterm is a sum of all the literal with or without bar within the logic system. So if you consider the maxterm, this is a sum of all the literal. That literal can be either with bar or without bar. It can be normal variable or complemented variable. So that a variable may appear either in its normal form or in its complemented form. That is, if it is a normal x, if it is complemented x bar it will be. So if a variable is 1, then it's complemented, otherwise it is in its normal form. So in the maxterm, which will going to get more weightage, so which is the complemented, that will going to get the more weightage. So for normal variable we have to put 0, for complemented variable we have to put 1. So here you can see that x, y, and now we have to find the sum of. So already we know that sum of literal, but if it is a minterm, then it is x dot y. But now we are dealing with maxterm, so it needs to be x plus y. So 0011, 0101, and this we don't. For example, x If it is a normal variable, that is 0. If it is a complemented one, then that will be 1. So that x0 and y0, it will be normal variable x plus y, and its designation is m0. If it is a min term, small letter m. If it is a max term, that is capital letter m. So that m0. So 0, 1, x plus y bar, and its designation is 1. Then 1, 0. We have x bar plus y, designation is 2. Then 1, 1, x bar plus y bar, designation is 3 here. So that this is how we are going to find the designation of this max term. So now we'll see about how this will going to work well with the 3 variables. So when we have x, y, z, at the time you can see the max term here. In the place of 0, it needs to be normal variable. Wherever we have 1, that needs to be complemented. So that 000 x plus y plus z, designation is m0 up to we have m7. That is the complete designation for a normal 3 variable. So that 0, 1, 0, in the place of y, we have to put y bar. So double 1. So in the place of y and z, I have to take complement. So if it is a normal variable, it will be 0. If it is a complemented variable, it will be 1. So wherever we have 1, that variable needs to be complemented. And it is a sum of all the literal that can be either with or without complement, or with or without bar, within a logic system. So we'll see the next one, that is canonical form. So what do you mean by canonical form here? Boolean expression is expressed as sum of minterms or product of maxterms are called canonical form. So if I am expressing any of the Boolean expression as a sum of minterm or a product of maxterm, then that will be considered as what? Canonical form. So here you can see that minterm canonical. So that is what we are representing it as a sum of minterm. So that f of x comma y, so the expression will be like this. For maxterm canonical form, it will be a product of variables or a product of maxterm. F of x comma y is equal to some Boolean expression. So this is how we are going to do the minterm canonical form and maxterm canonical form. We'll see the definition here. The minterm canonical form expression is the sum of all the minterm, and each minterm contain all the variables. So if it is a minterm, that is related to sum of all the variables. So if it is a max term, the canonical expression is the product of all the max term. So this max term will be the product of all the max term. So and each max term contain all the variables within it. We'll see the next topic, that is what? Conversion of SOP into canonical form, that is sum of product into canonical form. So it is a sum of product, then we have to deal with this minterm. So if it is a product of sum, then we have to deal with this max term. If it is a minterm, then I have to write its designation as small m. If it is a max term, then I have to write its designation as capital M. So now we'll see how we are going to have a conversion of this SOP into canonical form, that is sum of product into canonical form. So what we have here, x plus x bar y plus x bar z bar. So here we have 3 variables x, y, z. So in the first value, I missed out with this y and z. Here we don't have z, so here we don't have y. So in order to make it as a complete value, then we have to have a complemented and normal variable with this x, so that it will be x of y plus y bar into z plus z bar, plus then this x bar y into z is missing, so it will be z plus z bar. So as we all know that variable can be normal variable or complemented one. So I have to take both along with here, so that z plus z bar, then plus x bar z bar into y plus y bar. So after that I have to multiply x into y, xy plus xy bar into z plus z bar will be as it is. So here x bar y will be multiplied with this value, so that x bar y z plus x bar y z bar plus x bar z bar will be multiplied with y plus y bar, so that x bar y z bar plus x bar y bar z bar. So now I need to multiply this xy plus z bar, so that what I am going to get, xy into z will be xyz plus xyz bar plus then xy bar will be multiplied with z, xy bar z plus xy bar z bar, and I am going to write the remaining variables as it is here. So then I have to find out, do we have any repeated variables in this expression, so that we can get to know that these two variables are same, that is x bar y z bar. So instead of writing it twice, we are going to write it only one time, so that here x bar y z bar will be written only one time and remaining variables will be as it is. So now we have to find its designation. Already we got to know about the minterm. So wherever we have complemented, there I have to write 0. Wherever we have a normal variable, that needs to be placed with 1. So if I consider this as a normal variable, 1, 1, 1. So if it is a 1 to 1, if I take a 4 to 1 format, 1, 1, 1, 4 plus 2, 6, 6 plus 1 is 7. So that is, its designation is 7. In the same way, I can find M6, M5, M4, M3, M2, M1 and M0. So how we are going to find the sum of the minterm? So that is what? F of x comma y comma z is equal to, we have to use a symbol called summation, and I am taking a designation here that includes 0, 2, 3, 4, 5, 6, 7. This is how we are going to find the conversion of SOP into canonical form. We'll see the next question, AB plus AB C bar. How we are going to do that? First, I need to find the missing variable, that is C here. So it will be AB of C plus C bar, and remaining variables will be as it is here. So I need to multiply this with this value. So ABC plus ABC bar, then ABC bar. So now I have to find which is the repeated variable. So this is the repeated variable. So instead of writing it twice, I will just write it in only one time. So it will be AB C bar. This is how we are going to do the conversion of SOP into canonical form. So we'll see the next one, that is conversion of POS, that is product of sum. So we are finding the product of sum, or we are converting the products of sum into canonical form. So we'll see the question now. A plus B plus C into A plus B bar plus C bar into A plus B bar. So which variable is missing here? That is C, right? So then A plus B plus C and A plus B bar plus C bar. Then in the place of C, that means we are dealing with product of sum. So as we all know that if I multiply any variable with its complement, then that will be equal to 0. So instead of writing this one, we are just going to write it directly, that is as 0. So after that, A plus B plus C into A plus B bar plus C bar into, so we got to know about this one, C into C bar. After that, it will be 0. Then A plus B plus C into A plus B bar plus C bar. Then we have to multiply this C into C bar with this A plus B bar. So that A plus B bar plus C into A plus B bar plus C bar. So after that, we have to check, do we have any repetitive variable here? So we have to check, do we have any repetitive variable here, so that we can observe that A plus B bar plus C bar is repeated one. So that we have to write that variable only one time instead of writing it twice. So that includes A plus B plus C and A plus B bar plus C bar into A plus B bar plus C. So now we have to find the max term. So already we know that if it is complement, that is 1. If it is normal variable, that is 0. So that A plus B plus C. So in the place of A, B, C, I am just going to write 0. So 0 plus 0 plus 0, it will be 0. So then A plus B bar plus C bar. So here 1, 1, it will be 0. So then what it will be? 2 plus 1, it will be 3. Then here it needs to be 0 plus 1 plus 0. So that in the place of 4 to 1, we have 1 in the place of 2. So it will going to be 2. So its designation is M0, M3, M2. So for min term, we are going to use the sum of values. For max term, we are going to use pi. So there I have to take its designation as capital M. So that f of A, B, C is equal to pi of M of 0, 2, 3. And here we have one more problem that will be for the assignment. So here we have one more problem, that is the assignment question for you. So find the solution and let me know the answer in the comment section. It's all about today's session. Let me meet you in the next session. Thank you.